Today I'm going to show you the step-by-step method to solve any moments question for O-level physics. And I promise you that if you just apply these 3 steps that I'm about to show you, you can pretty much solve any moments question. Alright, so first of all, for a moments question, you always want to identify your pivot first. Right, that will always be your very first step. So your pivot is the point where the object rotates about. Right, so over here we can see that if you put a baseball bat, what's going to happen is that the entire baseball bat is going to rotate like this, right? It's going to rotate in this direction. So our pivot in this case is this point over here. The baseball bat is rotating about this point, right? So step 1 is to always identify your pivot first, right? I mean, most of the time the question will tell you the pivot also. Right, so once you found the pivot, step 2 is to group the forces into clockwise or anti-clockwise moments. Right, so over here we have 3 different forces. We have frictional force, normal reaction force, and weight. Right, and we're going to group these forces into clockwise and anti-clockwise moments. So a question that I always get from my students is, how do I know if a force produces a clockwise or anti-clockwise moment? Right, and the answer is very simple. Just think about how would the object rotate if the force was applied. So let me show you over here. Over here, we have the baseball bat, and we realize that the bat can rotate in 2 directions, right? The bat can either rotate here, or it can rotate here. It can go in the clockwise direction over here, or it can go in the anti-clockwise direction over here. There's only 2 ways that the bat can rotate. And let's look at the weight, for example. Let's see if the weight is clockwise or anti-clockwise. So you can see that when you pull the object down, the bat is obviously going to rotate this way, right? It's going to go in the anti-clockwise direction. So we can say that the weight is an anti-clockwise moment, right? Same thing for the normal reaction force. We can see that if we pull the object this way, the object is going to rotate in this way, right? It's going to rotate in the clockwise direction. So the normal reaction force is a clockwise moment. Lastly, for the frictional force, you realize that if you pull the object up like this, is going to rotate this way. Same as the normal reaction force. It's going to go in the clockwise direction. So now we can classify them into clockwise and anti-clockwise moments. Alright, so the weight is anti-clockwise, the normal reaction force is clockwise, and the frictional force is also clockwise. Right, so actually there's one more step over here. Let me call this step 2b. We want to find the perpendicular distance of the forces. Right, and I always get this question all the time. How do I find the perpendicular distance properly? Right, I'm going to show you a very easy method. So for example, let's say we want to find the perpendicular distance of the weight. You just want to extend the weight in a straight line, right? Extend the force in a straight line like this. And you just want to draw a 90 degrees line from the force to the pivot, right? That's always how you're going to find the perpendicular distance. So over here, a 90 degrees line will look like this, right? This one is 90 degrees. So now this one is my perpendicular distance. Over here, the perpendicular distance of the weight from the pivot is 10 cm. So let's try some other forces. Let's find the perpendicular distance of the normal reaction force. Right, so same thing, we extend the force. We extend the force in a straight line, and we try to draw a 90 degrees line from this line to the pivot. Right, so 90 degrees line will look something like this. Right, over here is 90 degrees. So now, this one becomes my perpendicular distance. My perpendicular distance of the normal reaction force from the pivot is 50 cm. Right, and lastly, let's do one more. Let's find the perpendicular distance of the frictional force. So we just want to extend the line in a straight line and draw 90 degrees to the pivot. Right, this line over here is our perpendicular distance. So our perpendicular distance for the frictional force is 30 cm. Right, so now that we found the perpendicular distances, we just have to make our equation. So our equation is basically clockwise moments equals to anti-clockwise moments, right? So in this case, it will be 0.50 times 0.3, right? The friction force is 0.5 newtons plus the normal reaction force. So let's call this normal reaction force N times the perpendicular distance, 0.50. right, is 50 cm, equals to the anti-clockwise moment of, okay, so the weight, the mass is 570, so W equals to mg equals to 0.57 times 10 equals to 5.7 newtons, right? So the weight is 5.7 newtons. So it's 5.7 times 0.1, right? So once we get this equation, we can just very easily solve this equation for n, right? So n equals to 0.84 newtons. So answer for this question is A. Right, so pretty much, I think the reason why students struggle is because of these two steps, steps 2 and step 2b. Right, but if you follow the methods that I gave you in this video, it's going to be very easy to group the forces into clockwise and anti-clockwise, and also to find the perpendicular distance, right? So just extend the line and draw a 90 degrees line from the line to the pivot. That will always give you your perpendicular distance. Right, so I hope that helps you. I'm Ting from the A1 Physics, and I'll see you in the next video.